This is A-level mathematics covering differentiating ln. So there's some basic rules about ln that I need to cover. So if I had ln of 1, that would give me 0. ln e, that gives me 1. And ln e to the n, because my ln and e cancel out, so that will leave me just with n, whatever my exponent is. Because use this rule right here with my exponent for log and ln, okay, right here, this would always be able to go in front of my function, whatever I have here, so it's going to be ln e. So if ln e is 1, that's how I'm able to just get 1 times n, because this exponent comes out to the front. That's how I end up with just that. Now, the next thing I need to deal with is the derivative of ln x. So the derivative of ln x is going to be 1 over x, where x is going to be greater than 0. Now, I'll explain to you why that's going to be greater than 0. So if I go clear in my calculator to try and prove this, so if I go ln, let's go -1, I get a domain error. So domain error for all of these is actually going to happen. So if I go clear, ln -5, same thing. I get a domain error for all of them. So that's why x has to be greater than 0 to do the derivative. Now, we just learned over here that ln, so I'm allowed to have 0 for this. So ln1 is equal to 0, but that's not the same thing. Now, right here, this has to be greater than 0. That means it cannot be equal to 0. So if x is 0, I would get 1 over 0, and that would be undefined. So that one there is not going to be allowed. So x has to be greater than 0 for all of this. Now, this next part, we're finding minimum value of the function f of x equals 2x minus ln x. Now, here's the steps for this. I'm going to set my first derivative equal to 0. So I have to take the first derivative equal to 0, and that's going to give me an answer. And that's going to be a critical point. Now, I also need to know this over here. So I have my y prime and y double prime, so it's first derivative, second derivative. So when I plug in that critical point, whatever I get from my critical point, I plug that in to both of these. If the first derivative is greater than the second derivative, it's a maximum. If the first derivative is less than the second derivative, it's a minimum. So let's go through and actually do the derivative on this. So the first derivative is equal to, now taking the derivative of 2x is just going to give me 2. Now right here, this is going to be minus, that derivative is 1 over x. That's an x there. So there is going to be my first derivative. Now right here, it says right here, set my first derivative equal to 0, so I get 0 equals 2 minus 1 over x. Subtract 2, I get -2 equals -1 over x. Multiply both sides by x, I get -2. X is equal to -1. Therefore, I get x is equal to positive 1/2. So this is going to be the x value at my critical point. So this is going to be my critical point here. Now we're going to see if this is going to be a maximum or a minimum. Now, I'm going to take this and I'm going to go ahead and use this right here. Where's my derivative? Here it is. So I'm going to use my first derivative, and now I have to do a derivative of this. But to make this look a little bit easier, I'm going to go y, first derivative is 2 minus x to the -1. So I could bring the x from the denominator up and just give it a negative exponent. So that means exactly the same thing as this. So I have the negative exponent. Now I can take the derivative of this, because the derivative is always I'm -1 off my exponent. So y double is going to be equal, now take that derivative there, that goes away, and this one right here, so my derivative, so it always comes out front, so -1 out front, and there's already a minus, so that becomes a positive x -2, because I take one away when I take it down. So I get that. Now I have that answer right there. So let's go ahead and clean that up. So y double is equal to 1 over x squared. Now I need to check this. So I have my first derivative and I have my second derivative. So here's first, here's second. So I need to compare those two, see if I'm going to have a minimum or maximum on this one. So minimum value, here's my critical point, here's my x value at my critical point. Now from here, as I plug that in, let's go for here. So if it's y prime of 1/2, plugging that in, it's going to be 2 minus, now if I have 1 divided by 1/2, right here I get the reciprocal of that, so it's going to end up becoming 2. 2 minus 2, so y here first is 1/2 is equal to 0. So that's going to be 2 minus 2 is 0. Now let's do the second one. Y second 1/2, I get, this is going to be 1 over, and when I square the 1/2, that's going to be 1/4. Squaring 1/2 is going to be 1/4, and do the reciprocal of that, and I end up with y is 4. Now I'm comparing the two. I'm looking at the first, I'm looking at the second. So right here it says that the second is greater than the first. Second is greater than the first, so that's going to be a minimum for this value. So that one's going to be the minimum, so I know that is the minimum that I'm looking for here. Now next thing I need to do is, for this critical point, I need to plug this in to see what the y value is at that critical point. So I have f of 1/2 equals 2 times 1/2 minus ln of 1/2. Now right here, this is going to give me 1. So f of 1/2 is equal to 1. Now if I were to rewrite this, this would become 2 to the negative 1. There's my 1/2. It would be 2 to the negative 1 because 2 is in the denominator. So I'll rewrite it ln 2 to the negative 1. So that's going to be that. So as I'm doing this one right here, the negative 1 could come out front, which would make it a positive ln 2. So my answer for this one is going to be minimum value of the function. So I'm going to have an x value and a y value. So if my x is 1/2, my y value is going to be 1 plus ln 2. Alright, let's take a look at this next problem right here. This next problem, we're just going to take derivatives, and this is 4.3.2. We're going to take the derivatives. So I have chain rule here. Derivative of the inside times the derivative of the outside. We know, so if I were to substitute this and call this just u, all of this u, the derivative of that would be like this, which I have up at the top. It would just become 1 over x. So whatever I have inside there would be 1 over. So now looking at this one right here, so the derivative of the inside is going to give me 3 times, so the derivative of this is just 3. Now let's go to the outside. The derivative of ln is 1 over whatever I have here. So it's going to be 1 over 3x plus 1. So my final answer is going to be 3 over 3x plus 1. Now let's look at this next problem here. So right here, derivative of the inside. So the derivative of the inside is going to give me 3 times derivative of the outside, which is going to be 1 over 3x. I end up with 3 over 3x, which will reduce to 1 over x. C, I have right here, this is going to be the derivative of the inside. So this is actually all inside here. just so you know, derivative of all of that is going to give me 3x squared. So that's 3x squared times the derivative in the outside, which would be 1 over 3x, oh, not 3, just x cubed. Just x cubed there. Now, right here, when I put them together, it's going to be 3x squared over x cubed, which will reduce that by x squared, give me 3 over x. Now, I moved over to another sheet of paper so I could actually continue this. So this is actually example D, which it was, if you were watching it, it was actually on the bottom of that page, but I'm going to need a little bit more room for this one. Now, derivative of the inside. The derivative of the inside, so derivative of x is going to give me 1. Right here, I need to rewrite this. I will rewrite this here as x plus x to negative 1. Now, I could do the derivative of this. So it would become, this negative 1 comes down front, so it's going to be minus x negative 2, because I have to take 1 away from that. So that's going to be that derivative of the inside times the derivative of the outside, which would just give me 1 over my x plus 1 over x. Now, because all this right here could be considered in the numerator, so I'm going to write it like that. Because there's nothing in the denominator here, so I could just write it like this. So I'm multiplying this straight across, so I end up with 1 minus, I'm going to rewrite this, 1 over x squared times, right here on the bottom, I'm going to have x plus 1 over x. Now, this is kind of a trick that some people learned in 3-4. If you haven't learned it before, this is actually, it's not that bad. It's actually really helpful. So, I have a fraction over a fraction. So, I am going to multiply top and bottom by the common denominator of that, the top and bottom. So, top and bottom of the numerator and denominator. Now, if I'm looking at this, the common denominator in between that and that, since this has an x squared and that only has an x, the common denominator would be x squared. Now, distribute that into there. It doesn't have anything to cancel, so I'm left with x squared. Now, when I distribute here into this one right here, my x squareds will cancel, so I'm left with minus 1. So that takes care of all of my numerator. Now, if I do the same thing in my denominator, so I'm going to draw my arrows under, so that right here, since this is over 1, like this, nothing cancels, so I get x cubed. When I distribute here, the x on the bottom will cancel that. So I will actually take away one of those, so I'm left with just x. X times 1 will give me plus x. Now, given this information right here, I could look at it and say, hey, I could factor the numerator into x plus 1, x minus 1. My denominator is going to be x quantity, x squared plus 1. So I factored it all to see if there's anything left I could actually take out of this. There isn't. Now, all this for this derivative, yes, because when we got the answer here, this was the answer, but you need to clean it up. Okay, you have a fraction over a fraction, so you have to do a little bit of algebra here. Now, so this is going to be my final answer. Alright, the homework assignment for this one right here, practice page 57, 1 through 4 and 6. The homework is going to be 1A, C, F, G, H, J, 2, PD, 3, AC, 4, AB, and number 6. So I highly recommend it because guess what? I'm pretty sure you're going to see something like 6 on the test.